how many of you are actually technical people here, engineers, doing somehow? Oh, many, good. So NXP is actually coming from Philips. Back in 2005, it renamed to NXP, so I believe from the Nexperia. And actually, Philips was one of the first coming with a general purpose ARM-based microcontroller. We are talking about 32-bit, and that time it was really a game changer, because before that there were only 8 bits and some 16 bits, so MSP for 430, and then Philips came with ARM, and since then all the microcontroller based on ARM cores ramped up, and NXP was one of the first. And just to place, the NXP as a company. So if this is a Sigfox, so Sigfox enables communication. So the things are being able to, not to speak, but they are able to be heard. So NXP is actually, so if this is the Sigfox on this side, I mean, if these are the things, we have the things, and this is the NXP where it is. So we are providing, or NXP is providing components which are placed in your devices. A few more words about NXP. So NXP is it's a huge company. I believe it's among top 10 of the semiconductor business companies. And let's say they have 4 main product groups. So microcontrollers, microprocessors. I believe most of you, or who has a car, very likely their components are there. So they're also safety and security. NXP is actually the leader in RFID. So everybody using the contactless cards, most likely it's NXP. Connectivity, Bluetooth, Sigfox, as well as sensing. So tire pressure monitoring, pressure sensors, accelerometer, gyros, and all this stuff. So this is all coming from NXP. And we are only talking about components, not ready-made products. NXP is big also in terms of revenue. So I believe this was 2017, about 10 billion or 9-something billion dollar revenue. But the very important data is also how much they invested into R&D. So we are talking about 1.6 billion money being given to the new products, to the launches of new microcontrollers. So when we are talking about microcontrollers, we are talking about now components of very small chips which are able to do things which were done by PC computers 15 years ago. So on a benchmark level, so these guys, these things are doing more performance than Pentium and Celerons 10 years ago. And we are talking about very low power consumption in active mode. So we are talking about 32 microamps per megahertz in active mode. And we are talking about 100 megahertz clock speeds for the microcontroller. There are a lot of guys using microcontrollers, but they are just lacking the performance. So the next step is to increase the performance, either to go to the microprocessors, but with microprocessor we need to take care about power management, memories, interfaces, peripherals. But with microcontrollers, we all have there. So NXP is just coming with crossover processor. So we are talking about microcontroller still, but running on 1 gigahertz clock speed. So microcontroller with all the real-time performance clock just being clocked with 1 gigahertz. So why we are here, actually? There is a lot of potential with many things, and IoT is bringing new opportunities for those things. And Sigfox is enabling the things to be heard, and NXP is enabling things to sense, to be smart, and to communicate. I will not go into the numbers. These are the statistics which are available online. Just the growth. Accumulate the CAGR, so the growth rate is expected for this area. So we are talking about low power, wide area devices. It's expected to grow really a lot. So what is NXP offering in this? So many use cases, many applications. I will not go into details. I will not read just maybe the products. I'm talking about chips just dedicated to Sigfox communication are noted here. very often we are talking about utility meters, any kind of water, gas, electricity meters, and NXP has all the hardware needed for that. Of course, the application side is still on the customer side, because this is where all the customers are differentiating. But all the building blocks of these applications, of the products, are available at NXP. So on one side, we are talking about microcontrollers, on top sensors always. And the first thing is a sensor in IoT, and then, of course, the communication and Sigfox in this case. So another use case is maybe alarm event triggers. So I can imagine, pest control, so mouse traps, all this stuff. It's very interesting application for Sigfox, because I would like to know if something got caught, just not to get smelly in a few days. Fire detectors, leakage detectors. We already discussed a lot about that today. And another topic which is being mentioned many times recently, it's another, let's say, IoT hype word. It's predictive maintenance. It's very much connected to artificial intelligence, and for in artificial intelligence, you need to have performance. And NXP microcontrollers and microprocessors has all that. So just, to extend the usability with predictive maintenance, I believe there are many applications on the field. We have power, for example, water pumps, big water pumps, big engines. They have power, so we can do computation, we can do artificial, we can do predictive maintenance on but we don't have any connectivity there. And in that case, Sigfox can just send alarm when something is going away from the normal stage. And we can save a lot this way. Just comparing to the preventive maintenance, we can maybe reduce number of visits to the device, and we just come when it's really needed. Coming to the transceiver, so the smallest component in the, let's say, Sigfox communication, one of the solutions provided by NXP. What is very good about it? So it has two antenna inputs. So especially in the case where we need to cover multiple frequency ranges or the regions, we can have two antennas. So we can really fine-tune it to different frequencies like 868 and 900 megahertz for US. In the case of Sigfox, many devices are working on the Aloha principle. So it means that they are just sending some data. They don't care if somebody is hearing it. And it's more than enough. And this is just a transmitter. So it's very stripped down version. So it's lower cost and can work just fine in many applications. Just the value proposition of the NXP. So excellent performance. They are, let's say, in this semiconductor business, so for a long period, so very good power consumption and sensitivity. So fast time to market, they provide all the libraries, all the hardware reference guides and reference material, as well as flexibility. On top of that, so when we are talking about proof of concept stages of the various projects, it's very likely that we will use modules. Because the certification route with modules, with verified solution, Sigfox verified solution is much faster, and time to market matters a lot. So modules will be most likely the first choice in the first stages of the project. And of course, when the project volumes are ramping up, you go to the chipset because of the price reduction. So Inocom is another partner of ours, and it's using NXP chipset. So actually, this is Sigfox verified, so it's more or less plug-and-play Sigfox solution. It comes with libraries and protocol stack running on the module. So you just need to have external microcontroller being able to speak on SPI serial bus. Besides Sigfox-only modules, there are also modules offering Wi-Fi and Bluetooth. Maybe some of you will ask, why Wi-Fi? Because Wi-Fi can be used in the asset tracking applications. Why? Because we can just sniff for the MAC addresses of the Wi-Fi, and we send this address, and we can know where the device is located. Because each Wi-Fi has a unique MAC address, and based on that, you can do localization using Wi-Fi. Of course, you don't connect, you don't send any data, you don't lose power on Wi-Fi. You just need Wi-Fi to get MAC address to send where your asset is located. And this is the complete portfolio for all the regions with different capabilities. Just a few words about EBV on top. So EBV, as I mentioned, is a semiconductor distributor. And we are really coming, we are there with you on all the stages of your project. So with the idea, so for example, I'm traveling a lot across Europe, meeting all the kind of people like you, being at a lot of events, tracking what is happening on the technology side, so we can really discuss what is the best to be used in your project. Of course, the next steps, including logistics and the production. And when your projects are ramping up, when we are talking about really huge volumes, we can help you, getting this backup in the terms of payment terms, for example. Just maybe a few words what I'm doing inside EBV. So I'm covering segment which we call smart sensing connectivity, and I'm covering sensors, microcontrollers, up to the connectivity to the cloud. I'm following what is going on in the market. I'm really reading all the small prints. I'm talking to suppliers, I'm talking to customers, and I'm filtering it out for you to share it with you, what is the best to be used in your applications. And I'm involved really in the early stage. When you have an idea, I can discuss. I had also a case, a customer came with a great idea and said, okay, but the physics doesn't allow it. You will really struggle. And of course, the project was stopped, but at least they didn't lose any money. Of course, the first level of technical support we can provide. I had 2 workshops today. And of course, if you don't have a partner, or if you don't have internal resources, we can recommend you partners who can help you with your project, with your hardware to be really realized soon, because time to market is what matters a lot. So in these few minutes, I really wanted to, let's say, strip down what we are doing. I provided few information about what NXP is having here. And I'm around here, we have a booth. So you can stop by, we can discuss. And thank you for your attention.